This video is going to show the geometry and meshing process for the laminar pipe flow problem. So once you've done your hand calculations, you have a general idea of what the solution is going to look like, you can go ahead and fire up Fluent. So just double click on geometry. And while this is loading, another thing to take into consideration are the assumptions that are going into the problem. Whether it's going to be laminar or turbulent flow, what turbulent model you're going to use, what boundary conditions you're going to assume. And these types of things will become more evident as we begin to set up this problem and solve it. So this is the CAD modeler that the Fluent uses, and something that is important, a lot of the examples you find online use ANSYS 16 and earlier, which uses a different CAD modeler. So the setup's going to look a little different and be sort of confusing. So just bear that in mind. Now, the first thing we're going to do, since this is going to be a 2D problem, is we're going to change our sketch plane to the XY corner grid, so just like I did there. And to change the view, we can click on the Z-axis. Oops, sorry. Click on the Z-axis down here, and that'll bring us into the 2D sketch view. And before we get started, we're going to set our units. We'll go up here to File, Space Claim Options, and to Units. So anytime you want to change that, that's the easiest way to do it. And we're just going to stick with meters here for this problem. But you can change it to customary if you'd like. And then we're going to begin by sketching. So here's your sketch plane with different shapes you can use. We're going to start with a rectangle, obviously because it's a pipe, and we're just doing the 2D cross section for now. So just do an arbitrary size, and it's going to be 0.1 meter high. So just go ahead and type that on your keyboard, press Tab, and it's going to be 3 meters long, and press Enter. And then you can use the mouse to zoom out. Alternatively, you can hit the Home button, and there you sort of this 3D view of our 2D cross section or plan view to see the 2D model. Now, right now we just have 4 lines connected, and so it wouldn't really make sense to mesh these necessarily. So what we're going to do is hit Select. We're going to double click the line to select all the connected lines. We're going to hit Fill, and bingo. Now instead of 4 lines, we have a surface, and we're going to be able to use this surface to mesh. There's a lot going on in the CAD program. You can get deep into it, but realistically, you're actually just going to use Rhino for your capstone project or whatever you're working on, and you're going to import your Rhino model into this instead of actually using this model. So it doesn't really do anyone any good to get too deep into the weeds with this. So we can go ahead, save our project, and exit out of the CAD. So you can see once we complete the geometry, there's a green check mark, and we can move on to mesh. So double click this, and we'll pull up a separate meshing program. Well, that's coming up. Just for reference, this is what our problem is looks like. This is domain. We have an incoming velocity, atmospheric pressure, and a 3 meter long pipe that's 0.2 meters high. And so we just did 0.1 meter, and we're going to use an axisymmetric assumption to help ease the calculations. So this is our mesh model. It pulls up the geometry automatically, and sometimes it makes sense to hit wireframe so you can see the design better. And so the first thing we're going to do is go down to Mesh and right click and just hit Generate Mesh. And so it's going to use its computer brain to find out what it thinks is the best mesh for this rectangle. And now this is a little bit too coarse for what we're going to be using. We want it to be more finely meshed so you can have a more precise solution. So one way to do that is go up to Mesh Control and hit Sizing. And now you can see that this is coming with geometry selection. We have nothing selected yet. So what we're going to do is we're going to select 2 of the edges, and we're going to tell it how many times we want it to be divided up, how many sections. So if you go up here to Edge Selection, and you hit this, and you control click the other side, then click that, click apply, and now you can see it shows that you have these two edges selected. And so if you go to type, you can say how many numbers divisions do I want between these two edges, and we'll say 10. And now you can see out of the mesh it created this new thing, this edge sizing that's going to use when you update the mesh. And we're going to do that between the other two edges, so we're going to go do the exact same thing. And we're going to select the two long edges here, apply, and number of divisions for the this longer edge, we're going to say 100. And now I have two edge sizings, and so we're going to do is click update mesh, and it does some math. And if you click mesh, now you can see this new model it came up with. Now this is good. It's a lot finer mesh than what it originally created. One issue that you may or may not want to resolve is the fact that it gets sort of bunched up here automatically towards the corners, which could be good. It depends what you're doing, but I'll show you one way to fix that. And you can just go, it's pretty simple, go up to mesh control and do face meshing, and you just select this rectangular face and hit apply and update. So it adds it down here, and I click the mesh, and you can see now it's a little more even and more evenly distributed. So one last thing that you're going to do in all your projects before you exit out of the mesh control is name the different parts of where you're going to set the boundary condition. So I hit edge control, and then I selected this edge here on the left. I'm going to right click and create a name section. This can be our pipe inlet, and I'm going to do the same thing on the right. This will be our outlet, and then here on the top, right click. This is the top, self-explanatory. And then the bottom side is where it's going to be rotated about the axis of symmetry, so call that the axis. And this will make our life easier when it comes to solving the system. And after that, you're done with the meshing, and you can save it if you like. Well, you'd have to go back and find it. And then you go and exit out. And then you can see for some reason the mesh doesn't automatically update. You see this yellow lightning bolt at the side. So to fix that, you're going to right click, update, and now you have green check marks by the geometry mesh. You're ready to set up the problem.